Scientific analysis of the ice cores reveals that the volcanoes affect our planet's temperature in several ways, because volcanic ash from eruptions is not the only cause of a sudden freeze. Volcanoes have another weapon. A gas that can actually reflect the energy from our only heat source, sunlight, back into space. Along with the ash cloud, volcanoes pump a cocktail of gases high into the atmosphere. Volcanologist Dave Schneider analyzes these gases by flying over the craters of active volcanoes. His laboratory is the state of Alaska, the most volcanically active area of the United States. Today, Schneider is flying to Mount Spur, an active volcano that has been smoldering over the last year. He will fly directly over Mount Spur's crater and through its gas cloud.
Security 357, where are you going?
We're going to Mount Spur.
Runway 6 left, about 3.5 miles in trail. They have a 60 knot overtake.
The horizon is littered with volcanoes. Schneider knows them all.
There's a lot of beautiful volcanoes in Alaska, and one is more interesting than the next, and it's hard to come up with. It's like asking which of your kids do you like the best.
After an hour, they arrive at the simmering volcano.
And right now we're just flying over the caldera rim from an eruption, tens of thousands of years ago, formed a large caldera at the summit, and then the new summit here is a volcanic dome that has grown in that crater afterwards.
In his airborne laboratory, Schneider gets down to work.
What was our altitude at right there, Ron?
82 right now. You want a little bit lower?
Schneider is analyzing the volcanic cloud for clues as to how it alters the weather. It doesn't take long for him to find the volcano's secret weapon, the gas sulfur dioxide.
There's a faint odor of sulfur dioxide that you can smell as we fly by, just pulling it in from the air vents. That's exactly what we're trying to measure here.
When it comes to global cooling, sulfur dioxide is the most damaging of all the volcano's gases. Big eruptions blast sulfur dioxide high into the upper atmosphere, where it reacts with water vapor to form droplets of sulfuric acid.
Sulfuric acid droplets are very shiny, much like this mirror, and they reflect the incoming sunlight back up into space, which would have the net effect of cooling the Earth.
Imagine billions of tiny mirrors floating above our planet, reflecting the sun's light back into space. Far less sunshine reaches our planet, and temperatures drop. The effect of sulfur dioxide is so powerful that even non-explosive eruptions, producing little or no volcanic ash, can drastically affect climate. In 1783, Mount Loki in Iceland started to ooze sulfur-rich lava from cracks in the Earth's surface. It produced no ash, but lots of sulfur dioxide. This caused the average temperatures in the eastern U.S. to fall over 9 degrees the following year.